The scenarios Event Grid enables regarding integration and its advantages like additional reliability and resilience may sound familiar if you've worked with a few other Azure services. After all, something like Azure Service Bus offers likewise advantages. Azure Storage Queue as well, up to a certain point. And then there's Azure Event Hub, which can also deal with large amounts of events. So, how do these services compare to Event Grid, and what should you use when? Let's start with Event Grid. We just detailed it in this section, so you know that it's a serverless offering which supports event routing with near real-time delivery, and it also easily integrates with other Azure services and your own code. Good use cases here are serverless workflows, as we implemented, real-time notifications like notifying a service when a blob is created, and in general, event-driven apps. Azure Event Hubs is a big data streaming platform and event ingestion service. It's capable of receiving and processing millions of events per second from any source to any destination. Key features here are the high throughput support, it's definitely built for high volume data streams, integration with blob storage, and Azure Data Lake, and the low latency. That makes it a prime candidate for managing telemetry data, for example from IoT devices, but also for real-time analytics and data processing. Azure Service Bus then is a messaging service typically used in enterprise applications, which provides reliable message delivery with advanced features. Key features here are message queue durability. In other words, it ensures message persistence and reliability, much like the reliability and resilience features of Event Grid. It also easily integrates with other various Azure services and your own code bases. Use cases are, well, all types of apps for which the reliability of data delivery is a high priority. Think about order processing systems, financial apps that deal with money transactions, or workflow automation systems. Lastly, we have our Azure Storage Queue. We use that in the Getting Started version of the course. This is a simple, cost-effective queuing service for storing large amounts of messages. Key features here are its simple API. In other words, it is very easy to use. Its scalability is also a key feature. It can handle millions of messages. And here too, the reliability of messaging and the easy integration with other Azure services are key features. Good use cases are systems that require a reliable messaging queue, but that doesn't cost too much. Alright, so that's what they are. The use cases mentioned already point towards the best fitting scenarios, but let me summarize it. If you have a need for an event-driven architecture, where you need to react to changes in state or conditions, consider Event Grid. It's ideal for scenarios requiring real-time notifications and serverless workflows, like triggering an Azure function when a new file is uploaded to Azure Blob Storage. If you need high throughput data streaming and real-time analytics, consider Azure Event Hubs. It's best suited for scenarios involving large volumes of data ingestion and processing, like collecting telemetry data from thousands of IoT devices for real-time monitoring and analysis. If you have a need for enterprise messaging with complex workflows and reliable message delivery, consider Azure Service Bus. It's ideal for scenarios requiring message queuing, transactions, and guaranteed delivery, like managing order processing in an e-commerce application, where message reliability and sequencing are critical. And lastly, if you need a simple cost-effective message queuing for lightweight applications, consider Azure Storage Queue. It's best suited for scenarios where you need to store and retrieve large numbers of messages without complex requirements like task scheduling and background processing in a web application. Imagine you're building a system where different services need to talk to each other, like a data pipeline or a workflow. Azure Event Grid helps with this by acting as a highly scalable serverless system that distributes messages between services. Event Grid uses a pub submodel where one part of your system publishes an event and other parts subscribe to it. When an event happens, a message is sent to the subscribers. A few key concepts are important to know about, like event sources. These are the origins of events, like Azure services or custom apps. Topics are endpoints in EventGrid, where events are sent to. They help categorize and manage events. Event subscriptions define which events should be sent to which event handlers. They can include filters to manage which events are processed. And lastly, event handlers are the destinations for events, like Azure Functions, Logic Apps, or anything really via a webhook. So, an event is published to EventGrid from various sources, from Azure services to custom code, using HTTP or MQTT protocols, and EventGrid then distributes these events to subscribers, which can be other Azure services or custom apps. On Azure, it's mostly a matter of configuration and applying the correct security approach. That is not that different from what we've done for other services. When you want to publish events from your own custom code, the azure.messaging.eventgrid package will come in handy. An important advantage of EventGrid is that it can improve the reliability and resilience of your system. EventGrid automatically retries event delivery if it fails, and if an event cannot be delivered, you can configure EventGrid to store it in a dead letter queue for later inspection and handling. And that's it for this course. I hope you learned something new, and I hope this course was worth your time. I definitely enjoyed making it, and I hope to see you again in another course. If you want to stay up to date on upcoming courses, feel free to follow me on X. My nickname over there is @KevinDocs. Just one more thing before I go. You're ready to be awesome.